the most interesting thing I think I've seen so far is what I call the sim to sim to sim to real. You train on one type of physics engine, you show that it generalizes to another physics engine, and then you show that it can jump to another physics engine, and therefore it improves your generalizability when you actually jump to reality as well. Because reality is just another type of physics engine. So you're training a policy that can generalize across these types of physics engines.
Hello and welcome to Dream Machines, the show about physical AI, robotics, and the future of the human experience. I'm Evan Helda, and I'm here to learn with you about how to utilize these tools and navigate this transition. Because one thing is certain, as intelligence escapes the screen and enters the physical world, it's going to challenge our sense of self, of reality, and of what it means to be human. So this show is not just about where this tech is going, it's about where it's taking us. If you enjoy this episode, please be sure to share with a friend and leave us some stars on your favorite podcast player. And for deeper dives on these topics and more, check out our newsletter over at dreammachines.ai. We'd love to have you join our growing community of thinkers, creators, and doers. All right, folks, welcome back to Dream Machines. If you want to understand what it actually takes to get robots out of the lab and into production, this one's for you. Today, I'm joined by the co-founders of Bifrost, CEO Charles Wong and CTO Aravind. Bifrost is one of the leaders in synthetic data generation and evaluation with simulation, and they have one of the most impressive sets of tools that I've seen out there to date for helping robotics teams train, test, and deploy autonomy into the real world. So in this episode, we get into what most teams still get wrong with simulation and synthetic data, why real-world data alone is not enough, why evaluation is becoming the real bottleneck in robotics, and how the best teams are closing the infamous sim to real gap. This one is a can't miss, in my opinion, if you're building on the front lines. These guys are some of the sharpest founders building this space today, and they've been at it long before the physical AI hype train left the station. I found their insights super valuable and rich with signals from the front lines. So with that, enjoy this episode with Charles and Aravind. First off, how are you guys doing? What's new? How are things?
I think that never has been a better year for robotics.
Hell yeah. Amen to that.
It's crazy, right? Because we saw the whole arc. It was like from having to educate people on what like AI was to what generative AI was, and then to what robots are, and just like living through that whole arc has been like a nice journey.
You guys timed it pretty perfectly, I think. I mean, you started way before physical AI was a word. You started before robotics was as hyped up as it is. If I recall, I think I saw you guys pop up on my radar like 3 years ago. Is that when you guys started roughly?
About a little more than that. But like, when we started the company, it didn't feel like we timed it just right? Like it felt like we were too early. I remember we were pitching our first like round of VCs. What they were asking, what is AI? B, you mean robotics? Robotics sounds very uninvestable. You're not even building robots. You're a dev tool for robots. And you're like, oh God, okay. We'll get there, right? And now it's paying off. So
I think that's part of every major success story is that when they first launched the business, it does feel a little bit too early. But the founders had the vision. They had the instincts that they were just early enough that there's going to be the opportunity to build the foundational capabilities to be paddling for the wave when it rises versus having to catch up to it. So kudos to you for that. Before we jump in here, what would make this a home run for you guys? I'm excited to share this out with your friends, family, colleagues, investors. What story, what points, what ideas do you want to land?
I think maybe one of the key ones is like, what does it actually take to deploy robots? I think that's like the unique insight that we have. Like, there's like two groups of people, right? There's the folks, in the labs. Now this year they're starting to like slowly deploy, but deploying robots into the wild. What does it like actually take to deploy those robots? And I think, being able to share that perspective with a lot of the customers they're working with, and also like a lot of the investors, and like, hey, these are that unique perspective and like that edge and insight that we're seeing from all our customers who are actually deploying robots into the wild. I think that could be an interesting take.
Awesome.
Charles, anything on your end?
No, I think one is that, like, Evan, to your first point, like we've been building this and thinking about this for a while, right? We're not just Gen AI groupies who jumped on when foundational models became a thing. Very much, very much.
Gen AI groupies. I'm going to steal that term. It's definitely a thing.
We've been thinking about this since we were in college, right? And like working on it in various forms, right? The other thing, like I think to Arvind's point as well, like we have a unique vantage point where because we work with so many different autonomy teams, we see a lot, right? And we see the common failure modes, we see the success paths. And that's an interesting place to be as a sim tool, as a dev tool across the stack, right? So just I think want people to know that about us.
Yeah. That's awesome. Let's dive into all that. Go ahead, Aravind.
Double clicking to what Charles said. It's like every customer deploying robots, they just fall into the same traps.
Yeah.
And it's like, for us, it's just like, guys, you will fall into that. Just don't fall into it. But like, no, but I want to try it. And they'll just like fall into the trap. It's like, if we can like, hey guys, these are the common failure modes. Avoid them the best you can and like do these things right before. So it's like just like helping them course correct earlier. Because we just see these failure modes again and again and again at all stages. You may be a hyper-scaling startup that raised like $2 billion. You may be a giant MNC. You may be a small startup. They all make the same mistakes, which is crazy.
Well, let's keep pulling that thread because I think it's a really interesting place to maybe start. What is that most common failure point? Is there one big failure point they're all repeating? Is there a basket of them based upon certain verticals? What are you guys seeing currently?
I think the biggest one is actually how these robotics teams think about testing, right? So the very traditional, there's two groups of folks, right? One group of folks is like, okay, we're going to just go out and collect as much real world data from some kind of test platform, right? Maybe it's a humanoid, maybe it's a YAM arm, maybe it's something in a very controlled environment, and then they'll use that as their like test set. The other one is like just like, okay, we're just going to manually roll this out and get a human babysit the system while it's rolling out these policies. And then they will get like a certain score from this, like, maybe it's like a 80% success rate. And then they will then take that 80% success rate and then they'll go to their management and say like, hey guys, we think we have achieved like a significant level of performance. Let's start rolling this out. But they don't have the discussion, which is like setting the expectation of, hey, these are all the scenarios that I need to handle in the actual wild and discussing them with the end users, right? So let's just take, for example, let's say you are doing industrial manufacturing, right? You need to be able to pick and place very specific parts and put them on like specific places in the factory. There's actually a finite number of scenarios that you need to be able to handle, but most teams only test like maybe 30% of them before actually going out into the wild because they just don't have like the ability to test the other 70%. But like sitting down, setting the expectations with the management folks and like, okay, let's define the level of autonomy that we want to roll out and the number of scenarios we want to handle. And like having all of that discussion beforehand, I think it's something a lot of teams skip as well. So as a result, you get this expectation mismanagement where people think that the system can do all these things, but in actuality only can do like 30%. And it's like, oh, why is it failing in production? You have all these like back and forth.
That's a useful insight. So when you guys talk to these customers, and this kind of kicks off the first question I want to open with, how is it that you guys are helping them avoid these failure modes? Like when you go in to talk to these customers, what is your story? Perhaps within this answer, you can kind of give us the thesis of the business as well. So we can kind of pack a couple answers into one here. But when you go talk to a customer, these guys probably look at you and they think, what do these guys know that I don't? And they also probably have a bias towards real world data oftentimes and not synthetic data. And they look at you and they say, these guys haven't built robots. What are they? And again, same kind of idea. How do you quickly earn the credibility and trust and then convince them to avoid those pitfalls? And then from there, what is the general story and thesis of Bifrost that you try to land with them in that first interaction?
Yeah. Maybe I can answer the first part, then Charles can answer the second part, the thesis.
Sure.
So the interesting part is, when folks actually come to us, a lot of the times it's just like, hey, we just need more data of X, like a specific scenario. So they aren't even going into the part of like, hey, have you guys built robots or not? And fun fact is, when me and Charles first started the company, we actually built robots.
Perfect.
So we actually built what looked like physical intelligence, like first product. And it's like a whole bunch of like stuff that we posted online. But we used like a UR arm. And synthetic data was just the way we trained it. We tried to sell it to factories, but all the factories were like, if you want to sell us this whole thing, you have to build an entire production line. And then we realized it wasn't like a venture scalable business at that time. Yeah. Right. So coming back, when teams come to us, their first thing is like, okay, we're building this autonomy system. The performance is not good enough. We are failing in a whole bunch of scenarios. We just need data for XYZ scenarios. So that's usually like the opening point. When they'll come to us and they're like, can you just give me more data for X? But then we tell them like, hey, first of all, let's slow down. We can give you guys the data, the tool to generate all that data. But let's first look at your evaluation stack, right? Like, how are you actually determining where the models are failing? And this is actually the most critical part where a lot of teams fail, is because their evaluation set is either A, super biased, or it's just very, very low coverage. For example, let's say you're building an autonomous boat. What most teams do is they bring the autonomous boat to a specific port in the world and then just collect all the data from that specific port. Right? So their test data is only of that port of specific weather conditions. Same for an indoor robotics company. They go to a few types of indoor households, they collect a whole bunch of data, and that is their small test set. And whatever metrics you're getting from that is actually like a false perception of performance because it's just on a small subset. So what we do is we come in and we say, hey guys, let's speak to your end users and find out what are the scenarios they care most about. And let's map out all the possible scenarios that your system needs to be able to handle. Right? So this is like a scenario grid of all the different permutations that the robot needs to be able to handle. And then once you can map that all out, now you have a truly diverse, high coverage test set. And then what we do is we map your real data to that. And then you can then see that, oh, actually, I only have a 30% coverage of all my test sets all my scenarios that I need to cover. And then that's when we begin the journey, right? So now you have your benchmark, which is high coverage. We start testing against it, and then we hill climb that benchmark. And then over time, the end user comes in and they add in new requirements and new operate scenarios. And then your benchmark constantly grows as well.
That's interesting. Question on that 30%. So how exactly do you guys determine that number and quantify that? And how does the customer or you understand what 100% should be?
Yeah. So I think the interesting part is we'll never be able to hit 100% because you can never get all the long tail scenarios.
Yeah.
Right. So the way we think about it is there's two types of coverage we call. The first one is it's quite straightforward. It's just operational conditions. So the way you can think about this is let's take the boat example, right? Let's say you're deploying an autonomous boat and you're putting it in a port. There's actually a few key conditions that you care about. So maybe it's sea state types of boats, different types of weather conditions, different types of collision approaches, approach angles. All of these parameters, you can actually ask any sea captain or any domain expert, and they'll be able to list them all out for you. We list them all out, and then this forms a permutation grid, right? So you can think you're doing parameter sweeps, but you're doing parameter sweeps across scenarios, right? And this forms this elaborate grid where it covers every single permutation, right? So that's bucket one. Bucket two is what I call these anomalous long tail scenarios, which is a giant whale comes into the scene. A plastic bag is covering a sea lion and it's flailing about. All these very weird things. These things actually, AI agents are really, really good at coming up with these long tail scenarios. And humans, as they see these things come up, they add them to the long tail bucket of stuff as well. And this is the same approach that Tesla has taken as well. And it's just a thing that you constantly grow this a long tail scenario library. Right. And the interesting thing that we have seen, sorry, go ahead.
I was saying that's a really helpful way to break it down.
Yeah, because this one, the first bucket, is really easy to quantify. But the second bucket, which is like all these anomalous long tail things, you can't really quantify because it's an infinite number of scenarios that can happen. Right?
So you used a fancy word earlier that I doubt most of my audience knows, which is parameter sweeps. And since I'm on the mission to help educate people on the technical elements of the space, can you quickly define what parameter sweeps are and why they matter?
Yeah. So the way you can think about parameter sweeps are, let's just take a super simple scene, right? Let's say you are outside and you want to be able to just detect a chair. What a parameter sweep would look like is, let's say I want to parameter sweep the lighting conditions. It means I want to move the sun angle to all the different parts of the, like from sunset to sunrise, through all the different angles. So you see the chair at all the different lighting angles. So that's what it means, like parameter sweep through the lighting angles. So you could also do a parameter sweep to different types of chairs, right? So modern mid-century chair, an old antique chair, chrome metal chair. And that's like parameter sweeping through the object types. And there's also parameter sweeping through the angle at which you're viewing the chair. So you can see how these like compound really, really quickly. And the goal really is just like, can you provide these teams with these high coverage data sets so that they can test and see where their model is failing even before they deploy it? So a lot of the times they would generate these tests, these parameter sweeps, and then they'd be like, oh, actually it fails on a chrome chair at this specific angle and this specific lighting condition. We didn't know that this would happen. So they'll go in and they'll try to fix it.
Got it. Super, super helpful. So we went deep in the technical rabbit hole, which I like doing in the beginning because it gets people hooked on what this is and why it matters. But let's pop up a level. Go from CTO perspective to CEO perspective. Charles, take us back to the beginning and maybe give us that headline thesis and mission statement you guys had when you started the company, and tell us a bit of the origin story about how you guys met, how you guys decided to jump into this problem, and kind of what was that aha moment that this problem was worth solving and that you guys are the right team to go solve it.
Yeah, for sure. And I'll also maybe answer a little bit about your question earlier about, what does it take to convince people that we know what we're doing, and that sim to real is surmountable, that fake data, our synthetic data is as good as real data, right? So taking us back, me and Aravind met in freshman year of college, actually, and we've basically been partners in crime ever since. I think we noticed in each other a bit of an ambition, a desire to do something a little more than what was just in the textbooks, right? And that, I think, was enough of a delta for us to go and do our own thing, right? We took slightly different journeys together. For me, I went down the autonomous vehicle route. So I was working at Nutonomy for a while. Actually, I remember my first ever internship at Nutonomy was barely even an internship. I basically got a warm intro to the director of autonomy at the time and just texted him that, hey, I don't have any skills. Can I come do something? Can I come work for you? And my jobs there included making Ethernet cables, like who makes Ethernet cables, right? I was like, and also driving their cars dangerously for scenario testing. I also worked a little bit at a VC firm in the Bay Area. That was an internship as well, just trying to get just trying to see what I like on the other side of the table. Aravind, you want to give a quick intro? Your background.
Yeah, please.
Yeah. Charles didn't mention this, but he was also building race cars.
Yeah.
That's cool.
He built a race car from scratch. He's underselling himself for sure. But he did a lot of cool stuff. He inhaled a lot of carbon fiber as well during that time. So his lifespan is significantly short.
Unlocked all the creativity.
Indeed. I will outlive Charles. So my journey was, I was doing a lot of AI research back then. So this is like pre-chat GPT, right? And my main thing was, I wasn't quite fulfilled with academia because you would publish like this. You would publish the approach of like, oh, this is possible, but then you wouldn't actually take it to fruition, right? So I was like, okay, I want to build an AI system from 0 all the way to 100, and I want to see what it takes to deploy an AI system into the wild, right? So what I found was there were a lot of people going blind in India at that point of time. And the main reason they were going blind was because they were going undiagnosed because like diabetes. So it seemed like a tractable problem. So what I built was using a smartphone, you could take a picture of your eye and it would tell you your level of diabetes and whether you would go blind or not. Right. And a mobile phone is so ubiquitous that you could scale it up really quickly. And the models, you can just send it as an app as well. We actually started building it and we actually put it through clinical trials and hit like a 99% accuracy in clinical trials.
Wow.
Right. And the cool part is just using a low-cost device, you could, I don't want to say replace a doctor, but you could augment a doctor and you could just do screens. So it's like, there was like that real epiphany moment. It's like, oh my God, this technology is so powerful. Like, what else could it do? Right. And I think for me and Charles, he came from the self-driving space. I came from that like medical side of things. We were like, this is such foundational technology that sure, it will make impacts like, it's chatbots, image generators and all that in the digital world. But what would this look like if it crossed into like the physical world? Like, how would manufacturing look different? How would transport look different? How would indoor household tasks look different? And we tried pitching this to a lot of VCs at the time, and we had to really, really paint this picture of like, hey, we are here now. There's this small little AI model that can do this, but imagine what it could do, right? And self-driving cars also weren't a thing back then. Right? They were just only taking off. Back to you, Charles.
I remember like in autonomy, I was working on like fleet management as well as perception systems, right? And so when me and Aravind came together, like the key thesis we were trying to figure out was what is the most scalable path to get AI into the real world, right? What is the best enabling tool or technology that we could work on, right? And I think simulation synthetic data very much came to the fore for us. And coming from the industry, it just felt so obvious to us at the time, like, why wouldn't you tap on an unlimited source of data or, of real world, stimuli for robots to learn from, right? It makes more sense. And, the funny thing is that when we actually got together and started trying to found the company, tried to raise our first round of pre-seed, that was a challenge, right? We were going to all these VCs and trying to explain what AI was, because nobody really understood what it meant at the time. Right, everybody was just thinking Terminator. Like, are you trying to build Terminator? What's going on? Right, and then eventually we moved over to the pitch evolved into like we're actually working on autonomous systems and robotics, right? And then when investors heard the word robotics, they were like, "Oh, robotics, terrible ROI, not investable, economics don't make sense," right? And to add, fuel to the, insult to injury, we told them we're not building robots, we're building dev tools for robots, right? Which is like, how many layers of abstraction do we have to go before we become totally uninvestable? But, we had a bit of a break when me and Aravind, so we did, we got connected to folks at NASA JPL pretty early in our journey, right? And we got connected to, which is a warm intro just to one of the planetary scientists working on the Mars rover, right? Cool. And I still remember it. Like, this was in the middle of COVID. Like, we were staying at our parents' houses, right? Like, we were in Singapore at the time because we were all locked down, right? And we were like, man, there's when we got the meeting, we over prepared, right? We were like, okay, we have this one shot, we have to nail it. And Aravind went away and created these beautiful like lunar terrain simulations and everything. Awesome. And then when we got there, we did the call. He was so impressed. He then said, "I'm going to organize a seminar for all my fellow planetary scientists to come in and listen to you guys."
Wow, that's cool.
We're like, well, shit just hit the
talk about a tail, as they say.
Exactly. We're still faking it till we make it, right? And so we got in the room there, and this was 3 a.m. in Singapore, right? We were pitching these NASA scientists, in our parents' homes, right? And I remember at some point during the meeting, my mom came into the room and wanted to give me a drink, and I was like, "No, Mom, I'm on the phone with NASA right now." Just
casual.
But what did come out of that was that NASA became our very first pilot project, right? And it was for validating Martian landing systems. So like the terrain you see behind me is from one of those terrain generations, right?
Nice.
Essentially, the new Mars helicopter at the time, they were trying to validate, where it's safe to land, right? Regolith, debris, all that stuff, and they used our data to validate those systems. And I think that gave us a lot of street cred. When later on we talked to more customers, and the pitch ball from there.
That's amazing. So you have this lighthouse customer. How did you go from creating some data and something in a very custom way? What came out of that? And then what was required to turn it into a product? And like, what does the actual product look like today? And from like a user experience perspective for someone who's just getting started using Bifrost?
Yeah, I think, the thing that people underestimate significantly about simulation synthetic data is how much setup is required, right? Like people think you can just download Omniverse or download Unreal Engine, chuck stuff in, and boom, you got simulation, right? But no, there's so much support required, right? There's 3D assets and environments, there's rendering pipelines, there's scaling up, there's compute as well. If you want to support such a heavy workload across such a large data set, all of that has to come into an experience that an AI developer can use, right?
Yep.
Like an AI developer isn't going to wade into the Unreal Engine docs and try and figure it out, right? It's a totally different vernacular. They just their time should be spent building robots. It shouldn't be spent figuring out quaternions and materials and textures, right? So a lot of our work was how do we abstract that away, present it in a way that an AI developer can understand. So today, our product is a web app, right?
Okay.
It's a platform called Stardust, where on one side is that it's like a 3D preview of what you're building being streamed into you on your browser, so you don't need compute. And on the right is a Python notebook, right? Where that's how you spec your scenarios and build your generations and all that.
Cool.
Right? So the idea here is that if you're a company and you want to adopt simulation in your company, instead of spinning up a 30, 50 man simulation team, with like 3D artists, technical artists, 3D developers, just use Bifrost. It's just one person, one seat, one experience as an AI developer. And you don't need all that additional support. Right? We are currently working on a new product that's going out to market soon.
Nice.
The product is specifically focused on robotics evaluation. Where the previous product, Stardust, was more around focused on perception, general autonomy. This one is hyper-focused on solving what we feel now is the hardest problem, which is evaluation, right? How, as a robotics developer, do I go from my initial policy next to like a parameter sweep across all the things that I care about, doing it in a scalable way, doing it in an easy way that I don't have to, again, wade into documentation, figure out Docker containers and stuff like that.
Wow. I have a lot of questions about that product. I'm seeing a lot of people go after that same space and interesting innovation happening there. We can get into that. But first one comment that you'll find fun. I was at AWS for 6 years, and my whole mission was to build a solution for 3D content creation, 3D content management, 3D asset pipelines, 3D asset configuration, trying to automate all that. We did launch it. It launched as a solution called Spatial Data Management, or Amazon Spatial Data Management. It's a much more primitive version of what I was trying to get to before leaving, but the code name was Nebula. And so you mentioned Stardust, and Mike, I think we have similar ideas of like 3D data, spatial data simulation type worlds, and
great minds.
Great minds, exactly. I'm determined to make Nebula be a product name at some point in my career because I think it's a great name.
Very close to their needs as well.
Yeah, exactly. Maybe it's destiny. Who knows?
Yeah.
You mentioned earlier this idea of making sim to real surmountable, and people toss sim to real around. It's become a buzzword. People oftentimes will use that excuse not even try because it is such a daunting thing. And there are some use cases where it's very, very real, and you're not going to overcome it anytime soon. The most common example is like deformation or interaction with certain types of cloth or liquids or things like this, where like the physics is just hard. How do you guys convince people that sim to real is surmountable? And then where is your focus and where are you guys nailing it and it truly is implementable for you guys? It's repeatable and you're not even having to struggle with it versus like, where's that sort of middle ground where you're close? And then where's that edge where you're just, it's in the future and you know it, you admit it, you're not going to get there yet, but it's on your mind. I guess we'll start with giving confidence and explain to them why it's even worth trying to tackle in the first place.
Yeah. So maybe I can like break it down into what does sim to real actually mean, right? And sim to real, all it really means is just, if you train something in simulation, does it actually translate to actual performance in the real world? Right. So most of the time, that's actually where we start, which is like, can we show you proof that it just works in the real world, right? And the means by which we get there, there's like a whole bunch of things that we can do, right? So it always starts with like bringing in the end user and like trying to convince them. And most of the time, they are not even like AI engineers. They may be a C-suite at like a large MNC, or it may be an end user that is just trying to automate some critical task in a factory, right? For them, it's like, okay, I have these 10 tasks that I need to do. Can you show me that these 10 tasks can be done, trained entirely in simulation? So it just becomes a train in sim, show in real life, or if I test in sim and I test in real, are the performance equivalent? So that's like the proof is in the pudding part of things, right? It's like, how do we showcase it to customers? It's just by doing it for them. The second part where your question is like, okay, how do you break down this whole sim to real thing? And I think you hit it exactly on the head, which is different domains have different thresholds of sim to real affordances, if you will, right? And sim to real has like these 4 big parts. There's like the perception sim to real, which is like, how real does it look? There's the dynamics sim to real, which is like, if I move a robot arm in simulation, is it the same movement in reality? And then there's what I call like the object to robot interaction, which is like contact forces. And the last one is like all your crazy deformable cloths and all that. Perception is something that we have solved, like that sim to real gap. So like, does it look realistic, right? And you can think like, you can use world models, you can use diffusion models, you can learn from the actual sensor imagery and transfer that onto your simulation. The second one, which is the robot dynamics, there's a lot of new solvers coming out like Newton and all that I wouldn't say they are a one-to-one, but they are a good enough approximation that customers have found it a meaningful test and meaningful training data already, right? So Molno-Act, like this paper that came out as well, showed the real to sim performance deltas are actually pretty good as well. And the most interesting thing I think I've seen so far is what I call the sim to sim to sim to real, which is you train on one type of physics engine, you show that it generalizes to another physics engine, and then you show that it can jump to another physics engine, and therefore it improves your generalizability when you actually jump to reality as well, right? Because reality is just another type of physics engine, right? So you're training a policy that can generalize across these types of physics engines.
Interesting.
Right.
That's cool. It's you put it in different physical realities along the way before it gets to like the ultimate one. And let it deal with like the variety and the unknowns, the uncertainties, etc. Right?
So it's like the thing is, what are the things that we can do at the speed of software? Right? You remove as much real world bottlenecks as possible to do things as fast as you can at the speed of software. And you just improve iteration time. And all of these are approximations, but if you can get the system to be a very, very good approximator of like the physics, then you can also approximate the real world physics and just generalize pretty well as well, right? So that's kind of how we've been able to overcome all those gaps. But coming back to the first part that I mentioned, that is majority is just like showing customers it actually works, and that's something that we have gotten to be very repeatable, where data comes in, we can calibrate the system and then put it out again.
Yeah. Well, I will add as well, like, and Aravind is hinting at it a little bit, like that's the technology when it comes to SimTril. There's also the trust aspect, right? The human part of it. You could show, skeptics, countless benchmarks, metrics, and they still might not feel comfortable deploying their robot into their environment if it's only been trained in sim, right? They still need a seal of approval from somebody. It's all transitive trust, right? And one thing that we've been exploring as a company is not just working with developers, but also working with regulators, right? You can think about heavily regulated spaces like maritime, in this case, like, warehousing, manufacturing, all that. The regulators, the certification societies and all that, who approve every autonomous system that goes out before it's actually deployed, they, and credit to them, they've been trying, but it's hard for them to regulate autonomy, right? There's so much that could go wrong, from the perception stack to the controls to everything, right? And that, they're not AI native, right? For them, certification has been ship hull integrity, propulsion systems, right? And now we're asking them to evaluate, perception and autonomy. That's a totally different ask, right? The only thing we've been exploring is, there's a gap here. Can Bifrost fill it? Can we be the platform for developers to battle test their systems and be the same platform that does the pre-check? So when they go to the evaluation authorities, they already have something ready to go, right? And there's a common language now, right?
Got it.
And just double clicking into Charles's point, because I think he brought up a really good point, which is real to sim is, sure, it's a technological problem, but I think more importantly, it's actually a trust building exercise, which is, how do you establish a set of experiments that both people can have like very high trust in? And like, how do you incrementally grow that set of experiments? So it's like, okay, we trained in sim, let's have these 10 scenarios where we demonstrate it. And like getting all the stakeholders to actually align for these actual robot deployments in like mission critical areas is actually really tricky, because there's multiple stakeholders that we're trying to bring to the table.
Yeah, so I can only imagine that sales process, especially for that last guy who's responsible for the safety element and the final putting the machine in the field, especially in these defense areas that you guys seem to focus on.
But I think that's we actually turned it around, and it became our unique selling, a value proposition.
Okay.
Right. So it wasn't actually a problem. It was actually that was the reason why people were coming to us, because it was like, oh, actually this makes certification much easier.
That's compelling.
Yeah.
So his anxiety was way worse before.
Way worse before, because like so many unknowns, right? But now it's like, okay, now I know what's tractable. I know how to approach the problem. And then you're getting all the stakeholders to sit around the same thing, which is like,
it makes a lot of sense.
Okay, these are the set of scenarios. Right?
He now has a story to tell to his boss why this is going to be safe, when he didn't really have that justification before.
And in my perspective, I feel like this is one of the biggest problems in physical AI, which is like, you have this system that has a promise of being able to do anything and everything, but no one is defining the bounds of the system. There's like, what can't it do? What can it do? And it's that expectation mismanagement. And that's like the big thing that we always see between like a vendor who's like building and selling the robotic system and the actual end user. And it's like, oh, but you told me it should be able to handle this thing. Why can't it handle this thing? Right? Like in self-driving, they got away with this by, having levels. It's like level 1, level 2, level 3, level 4. But we're still like, there's still some gray areas, and like, oh, actually, it's Tesla's thing, this or that.
Seems like you guys might have to agree with the customer up front on like your own custom leveling for what they're doing, and sort of have the same semantic understanding of that ladder you're climbing together, right?
Exactly. Our system is just a way for them to define that ladder and system easily.
Yeah. You need your own L1 through L4. This is a way to define that and get there and benchmark.
Like on the Bifrost scenario library, here are the suite of tests you have to pass to qualify for so-and-so regulatory authorities level 2.
Yeah. So I want to get into how you guys differentiate from other players out there. Before we do that, what's the biggest reason you guys lose a deal or customer? And I'm sure then from there we can talk about how you're filling it, but like there's got to be edges you bump into where the customer just doesn't go forward. Like what's the most common failure mode there in your engagements today?
I would say the most common one is actually they haven't viscerally, they think they can get away with enough real data.
Got it.
Right. So they'll come to us and they're like, oh, no synthetic data. And then our price point is a little high. So they'll be like, oh, it's, well, we don't need this now. We could just we can use real data. And this is typically when they have a good enough large amount of data, but they haven't faced the problem of actually trying to deploy the robot. right? So they haven't faced the visceral, it's failing in production pains yet, right? They can deploy in a one constrained environment and it's like working reasonably well.
The irony is that, synthetic data is incredibly useful, all the way at the beginning of the AI development process. When you don't have enough data, you need to bootstrap, you need to get something out for your first demo, your first POC. But the problem is that, from a customer's POV or user's POV, unless they put in the cycles and they've actually tried to deploy something, they realize it doesn't work, right? And they need to have a better data approach. That feeling of like, yes, synthetic data is the answer here, doesn't sit as viscerally with them. Right. The best customers that we've worked with actually have tried to build simulation in-house. Right. They
know the pain.
They know the pain.
They've experimented with the tools. They've tried to roll it out, and they realize that this is not something my team can just whip up overnight. I think this is something either like a whole company has to focus on. Right. And then they come to us and they realize then that the price point is very makes a lot of sense.
Yeah, there's this weird graph which you have. Is like essentially there's like a life cycle of these like physical AI robotics teams. At the very, very start, when they have almost like little to no data, synthetic data, they love it. They're like, oh my god, it's great, bootstrap. And then there's like it moves slightly further along, and they have like significant amount of data, like real world data. Then they're like, oh, I have enough data. I don't need synthetic data. And then they accumulate more and more, and then they try to deploy the system, and it's like, oh my god, okay, I need synthetic data. So it's like at the very start and at the end, it's like, okay, I need synthetic data. But in the middle, you think you don't need data because it's like, I have enough. I'm getting like reasonable performance. So let's keep going.
I feel like you guys need to create some kind of meme.
Yes, some kind of like, meme.
With meme is real.
Yeah,
it's like a synthetic data epiphany meme.
Exactly. And like, if you just look at the world's top like systems that have deployed autonomy, right? It is Tesla, it is Waymo. They're actually out driving the cars. All of them have huge internal simulation teams.
Yep.
Right? Because there's no way you can do testing at scale at the speed of software, right? You want to roll out a model update, you need to test a whole bunch of stuff. You can't expect to just like test it on the road itself. Right.
I'm going to have to go create this meme right after this. Yeah. I'm writing a piece right now about the future of simulation and like robot ops in general. I'll probably have to put it in there. And don't worry, I'll give you guys credit for it. Don't worry. Okay, so let's turn to the strengths where you're just like a hot knife through butter and you're winning super easily. What vertical markets is that occurring in, and for what use cases, and what kind of autonomous systems today?
Yeah.
So Charles, you can take this.
Yeah, sure. I think
if you train
we can kind of think of this in two phases,
does it actually translate
pre and
to
post physical AI Cambrian explosion.
Right. So most of the time, that's actually where we start. Which is
pre 2025.
Can we show you proof
right?
that it just works in the real world?
Physical AI was just a burgeoning term.
And the means by which we get there,
we hadn't really come into this world of humanoid robotics and like exoproliferation of VLAs and things like that.
Bringing in the end user. And like trying to convince
in the world
them.
of
Most of the
robotics
time, they are not even
traditional
like
warehouse
AI
robotics, robotic arms were definitely not
C-suite at
interesting
like a large MNC.
Right, it was too fragmented, too many different tasks, like no consolidation, not enough to make a market, right? And then you look at the broader autonomy space. You think about everything from drones, satellites, cars, boats, planes. And urban, of course, the classic, the big boy in the room, urban autonomy, right? The cruisers, Waymos of the world, right? Interesting, when we first started, because I came from the world of self-driving, right? We thought, urban autonomy was going to be our first customer, right? And that we would go hard, and this would be the space we grew. But I think when we did our user interviews, and we very quickly realized the incentive structures of the first gen of full stack self-driving companies was wrong. Because when you think about those early companies, their prerogative was to build as much tech as possible, build as much IP as possible, have it in-house, and then eventually get bought over by an OEM, and then that's how they build vehicles, right? No one at the time was thinking about actually manufacturing and shipping product, right? And, since you're an R&D play and not a product and revenue play, the way you procure technology is different, right? Bifrost in as a critical but ultimately point solution for a problem that you're probably facing, right? And they're like, oh, simulation, sounds really important and like a useful bit of IP. I think we'll build it in house. We don't want to buy it from
all of them did, right? Like look at Wabi, Torque,
Yeah.
look at
Exactly.
Wave. They all kind of applied intuition. Well, a little bit different actually, but they're also proud of their simulation stack. It's part of their product, but it's also so orthogonal to what their real end game is too. So it is interesting why they're so proud of it. It's like, great, you spent so much energy and time resources doing a thing that isn't really the IP that matters.
Totally.
Especially over time. Yeah.
Yeah. And so we had to, and from a business POV, we had to shift our focus into other areas like maritime, like aerial. And we realized here people were actually shipping product, right? They were trying to ship drones, they were trying to ship autonomous vessels. And now there was urgency. Now there was a timeline, right? And they didn't have, the talent, good talent is hard to find. They're not going to spend that talent, reinventing the wheel. They're going to buy the best synthetic data stack, the best simulation stack they can find, right? And so that was how we sort of grew that share of the pie over time. Post, physical AI campaign explosion, now you've got, the huge proliferation of, humanoid robotics, robotics in factories, manufacturing, logistics, right? And now everybody's trying to ship product, Now, early stage startups robotic startups can actually raise enough money where they can, ostensibly build manufacturing capability and do it themselves, right? And so now the incentive structures are different. And so now, it's a good time, I'd say, for dev tools into space like us.
Yeah, that's great.
The main thing to look at, is really what is the organization trying to optimize for, right? It's like, are they trying to optimize for reliability and performance? Or are they trying to optimize for hey, we want to try a whole bunch of different architectures to figure out what is the most performant one and what's the right way. So there's the product companies and then there's the research companies, right? And we're seeing a lot more product companies come up now who are chasing reliability with a sense of urgency. And they're like, okay, we want to win. Therefore, we need to move as fast as possible, right? But research is more like, okay, there's a whole bunch of questions we need to answer. What's the different types of data types we can try? What's all these different things that we can do, right? So there's really different within robotics. Each customer and each organization has very different incentive structures.
Yeah, it's an interesting exercise to go through each of them and map that out by vertical stage of the business. That's a very useful thing for any salesperson, I think, to do and think about as they go on an approach. So as you approach different companies who have different incentive structures, I'm experiencing this in my day job. There definitely is a not built here tendency.
Yeah.
And a lot of them, they do hire great talent. They're raising a ton of money. They can build it. A lot of them build it because things didn't exist, but now there's all these tools like you guys coming out that do. When you're competing against internal tooling that already exists, they've maybe already built, or when you hear they've already built something, what are the differentiating moats from a tooling perspective, infrastructure, UI, UX perspective, whatever it might be, that you guys are touting to really help them get off their internal development effort? And I guess this is another way to think about, I'm curious to get into the weeds a bit of the product and the tech and how you guys are differentiating from a lot of other companies out there doing this stuff. I'm seeing Pell Domains doing it in AV. You have Applied Intuition, I think, does a lot of this stuff. Honestly, I'm seeing world models, the world labs are starting to come after this space. And so, yeah, tell me how you think about competing, I guess, is another way to ask the question.
Yeah. And Arvind's gonna, just before Aravind gets into the weeds on the features and stuff, I think some of our biggest customers have internal simulation teams that we routinely talk about and go up against in some fashion, right? And it really, this is almost less of a robotic specific conversation or a AI specific conversation, just product specific, product, more broadly product principles, right? And I think one thing that we really try to hold ourselves to is how do we make their lives easier, right? Not just the robotics developer, the user, but also, the economic buyer, the procurement guy, the director of autonomy, is all the way up the chain, right? How do we make this a no-brainer for them compared to whatever they're about to spend on or whatever they're about to do?
Yep.
And so, which is why, like, when we compare ourselves against some, simulation tooling that's out there, like, one of our positions is that you don't need to hire 30 people on your sim team to run this and build this capability for you. What Bifrost above all purports is that you just need to provide one AI developer, one user, and you can start generating data within 5 minutes, right? And just the ease of onboarding, the ease of use from a non-3D, non-sim expert is usually more than enough to get our foot in the door, right? But once your foot is in the door, then the game begins, right? Because now you're being attacked from all sides. There's internal politics. There's new tools coming out, and that's where it gets kind of interesting, I guess.
Sure.
Aravind?
Yeah. So most of our customers have raised like $1 to $2 billion already. So, they also have the money to go out and build it. And most of them also like tried to build it themselves. The reality is, first of all, and maybe this is a thing that maybe most founders may not want to hear, but you just got to ship faster and better, right? That's first of all. And two, just make it super easy to use. But most important of all, I think you need to have a very opinionated take on how it needs to be solved. And our opinionated take is, we call it like the autonomous simulator, right? What we saw previously at almost every simulation company is all the scenarios had to be hand-built. Everything had to be done by hand. I have to go in, I have to define what 3D objects have to be, I have to define how the scenario plays out. As a result, there's this category called simulation engineering, which is you hire a whole bunch of people to manually program the simulator to do a whole bunch of stuff. And as a result, you're hiring like 30 to 10 people just to serve like some internal teams. And most of the time, the internal team can barely even keep up and serve the entire organization. Especially with like these larger organizations who are like, scaling, hyper scaling. There's like 15 different platform teams. And this one team cannot provide the data to help these like 15 teams. So we come in and say like, hey guys, you shouldn't be building scenarios by hand, first of all. Your data, your real world data should drive your simulator. So it's a data-driven simulator. It should inform what scenarios you build. It should inform the rail to sim gap for the photorealism. Your simulator should be driven by real-world data, and that's how you also close the sim gap, but also how you do less work, right? And you can produce higher quality data. So this concept of the autonomous simulator is really an opinion thing. It's like, how high conviction are you on this direction? And you're willing to commit all these engineering resources to build the thing. And most teams don't have that high conviction. They just do the simple thing, which is like, let's just build a simulator from scratch. They use procedural generation, use this, use that. And it's all on paper seems like the right thing to do, but they're not taking the high risk bet, which is like, oh my God, okay, how do we build real world data pipelines that can auto-define all these things and like generate these scenarios at scale?
How does that data flywheel work when you are trying to let real world data define the simulator and define synthetic data? Like from, if you're talking to an engineer that's trying to build this, like, can you break that down for us a little bit?
Yeah. So the way you can think about it is, let's say the data is coming from your camera. It actually has so much compressed information about the type of objects, the type of scenarios, the types of layouts, the time of day, the weather. There's all this like metadata.
Yep.
Essentially, we're just looking at this and pulling out all this metadata and using it to inform what you generate. And we help automate that setup process.
Got it. How is the automation happening? So let's take an example. Maybe take one people can relate to. A humanoid in the house. I see a bunch of packages on the ground. There's gaps that I'm identifying in my space. Like those pixels come in, and then you guys have like some kind of world model you're using to produce variations of that. Are you guys using like an LLM or VLM to identify that, and then you have humans sit there and go like recreate 3D assets that aren't in the room that should be? Like, what does that technically, the automation look like, and how does it feed into the final simulation or final experience that you guys enable?
Yeah, you're actually halfway there already. So it's like the image comes in, right? And you have both VLMs, which are very good at like general purpose understanding of seeing context and imagery, and you can actually have a very like structured prompts to pull out all this metadata. So it's like, hey, I want you to tell me time of day, I want you to tell me type of scenario, I want you to draw bounding boxes across all the different types of things. This is actually like 90 to 80%. It is good enough. And then you layer on top fine-tune like segmentation network that can look at all the objects and extract up all the objects. That goes into a different pipeline that from a 2D image, it can reconstruct a 3D object itself. Right. So what you're doing is essentially you're looking at an image, you're taking out the parts, and then you're feeding those parts into different pipelines to recreate those objects and things. Right. And you're also extracting the metadata of what's the lighting look like? What does the scene layout look like?
Yeah.
Right. And then you're recombining that to a physics simulation. So you go from 2D image to that 3D sim. Right. And the part is you want to come to a point where it is an autonomous simulator where your real world data is being piped in, it's informing your simulator, it's defining the tests, it's doing all these things, but you could go in and you can expand your coverage. Right? Because now you have full control over your simulator. You can just say like, hey, my real world data has these like 10 types of boxes and tables, but let's make it more crazy. Let's like increase the coverage. Right.
Where are we on that journey to just a fully autonomous simulation loop where agents are able to go and do all of and there's a term you guys use called data patching, which is this idea of like treating data like a bug fix. How far are we from a world where like you don't need a human in the loop to do really any of the stuff you're talking about?
So there's two ways of thinking about it. One is the safety side of me is like there should always be a human in the loop verifying the patches, which is like, hey, it identified the thing, you should fix it. And there's the other side, like accelerationist, which is like, oh my God, just automate the whole thing. It's like a non-safety thing. I think it's possible to automate the thing entirely, but I think it's unsafe. Simply because these are mission critical systems.
Yeah.
I think that another useful way to look at this is sort of like, fortunately, unfortunately, the way AI teams are set up in most companies today, they're being asked to build like their software engineering teams, when in reality they are R&D teams, right? And there's a difference, right? R&D teams are supposed to go out and do experiments, come back with a thesis, and you shouldn't be measured by the outcomes. You should be measured by the experiments you're putting into the work, the inputs, right? Software engineering is like, okay, it's a fairly structured thing. You have a spec, you build it, you build the feature well, you get a thumbs up, right? And somehow we're taking this very complex AI R&D process, AI development process, and being asked to deliver outcomes that look like software engineering, right? And that's often the engineering and versus management mismatch, where management is like, I'd love for, we need to ship by December. Before we ship, we need the model to achieve 95% accuracy, right? Firstly, where do they pull that number from? It's just something that, it's pretty arbitrary. And then now the R&D engineers have to go and figure out how we're going to get there, right? But AI R&D isn't so deterministic, right? So it's this relentless crawl, right? Even if you gave these, developers, all the right ingredients, right? The best data, the best pipelines, all the GPUs they could dream of. If you don't give them a recipe as well, the cake is going to taste like shit, right? So that's really what we're trying to think about when we build like this data patching loop, right? How do we take the principles of software engineering, like unit testing, like iterative patches and iterative workflow, and apply that to AI so that developers have an easier time of stepping their way up to something that actually works, right? That's how we think about it. And it's a continuous journey, right? One day AI development will be just a snap of the finger, but we're not there yet, and we hope that Bifrost is the thing that gets us there.
That's a really thoughtful approach for sure. Go ahead, Aravind.
To Charles's point, synthetic data is just like a tool Like it's like a small part, but the part where we see a lot of people like make mistakes is actually the how you use synthetic data. Right? Because it's like a lot of people actually like they may have like, maybe it's somewhat good enough synthetic data, but how they use the synthetic data, like the way they use it to train, their workflow, the approach, there's so many mistakes in that training and testing phase that actually sets up the project for failure. Right? So for us, it was like, okay, how do you build a more systematic workflow that is not just about how you generate the data, but it's like, how is that data used to train? How do you detect the failures? How do you pipe that back into the simulator to generate the right kind of data? So I think the most important word is are you generating the right kind of data? And are you training it in the right way? And I think that's the mark that most people miss. They just try to make like pretty images, essentially. They're just like, I generate an image, it looks like photorealistic, synthetic data is done. But they miss that two parts. Like, are you generating the right kind and are you using it in the right way?
Yeah. So this whole idea of finding, ensuring or measuring signal versus noise and understanding if a data set, a synthetic one or even a real one, is statistically meaningful and like moving the needle with model improvement. And it sounds like Stardust, the eval tool, is maybe the way to measure that. But like, maybe break down a little bit for us. How do you ensure you're avoiding like empty calories with the data? And how do you get the signal and the noise in a like sort of real-time way? Do you have to wait until you just get the policy in an eval and see how it performs? Or is there something you can do before that to understand how the needle is being moved on the model's capability or the policy's capability?
Yeah. Charles, do you want to take this? I can take this.
Okay.
So I think it just starts first with like the end user and what the thing that they're trying to achieve is. Setting up a really, really good scenario grid on the evaluations. That's like step one. And then step two is that, okay, once you have that really, really good scenario grid, can you map your real data to that synthetic grid? So you now have a real test and a synthetic test, but they both have different levels of coverage. The synthetic test definitely has a high coverage and your real test has a lower coverage. And then you're testing against the two. And number one, you're seeing equivalence, right? So it's like, if the model is failing on the real in some cases and passing on the real, is that happening with the synthetic examples as well? So that is also a confidence building exercise, but it's like, hey, actually the results you're getting on your real are reflected in the results in sim, right? Once you have those two, you can start to see the distributions. And your goal is essentially just to align the distributions so that over time, as you collect more and more data, you're just like whacking the performance scenarios down over time, right?
Just to add to that, like the key to this is, it starts before you even generate the first piece of data, right? It's understanding what data you should be generating, right? So it behooves you, and we have tools for this that we provide to our customers. It behooves you to like look at your current model, your failures, and figure out where it's failing, right? Do some clustering, do some embedding space, like filtering and stuff, and figure out, okay, I have achieved only 70% accuracy on this test set, right? That 30%, where is it failing? Oh, if I cluster it up, I can visually see, I can use VLM for this as well, I can visually see that, it's failing when there's a white box against the white table, or a blue box against a green background. And suddenly you say like, this is precisely the thing I need to fix. And, you can even then make assumptions like, oh, if I fix this cluster of problems, I can expect my model to jump by 10% accuracy because these are 10% of my failures, right?
Got it.
And then you feed that directly to your data generator and you go from there, right? That's, hinting back to earlier about that systematic loop. How do we get people more iterative to success?
That's also helpful because I think, at least for me, so many people, it's like simulation is a sexy topic, but so few people see into the black box of exactly how to set this up for success. So I appreciate that breakdown. Let's look into the future as we wind things down here. I use this term data diet between synthetic versus real, and like what that right balance is today versus tomorrow. What do you think if we look, let's say, I know it's so hard to predict the future because the future is here and it's evolving so fast, but if you had to guess 5 years in the future, what is that data diet? And do you think that we're going to get to a point where it's all simulation, it's all synthetic, and you don't even need to touch real world data? Or do you think real world data is going to always have a place, even in 5 years when it's incredibly easy to create everything in edge cases?
I have a bit of a left field answer here. Maybe this is less technical, but this is more like, it's just we're talking 5 years out, let's talk vision a little bit, right? When we think about real versus synthetic data, we're trying to think about what do we need to dream up or hallucinate for robots to learn from, rather than just experiencing in the real world for themselves, right? And for humans, when humans learn, we just call this like either, it's called either doing the thing or imagining it, right? Like the difference between the way robots and humans learn, right? Like if you're a human, if you're a robot, like let's start with the robots, right? Let's say you're a robot, you make a mistake in production, and you have to go back, and then your engineer has to figure out where did it fail, how do we improve this, how do we collect more real data, improve the data set, retrain, redeploy, yada yada, right? For humans, let's say we go to work, we make a mistake. What happens? We go home, we reflect, we ruminate, we play out several scenarios in our mind of how this could have been better, and then tomorrow we come back to work, we do a better job. There was no retraining, right? There was no, figuring out, collecting more real data and practicing until we get it right. You could just, for many tasks, right, you can just sit and reflect and imagine, right? So I like to think of imagination as a proxy for this. Where like eventually robots will get to such a point where they are able to autonomously imagine and self-learn and self-correct on the job, where this paradigm of like taking it back and retraining, whether with real or synthetic data, that will subside or like reduce significantly. Yeah.
What's the role of your business in that future? I mean, that could come pretty quickly. Like I just had a meeting with a customer that's building not a VLA, but a video action model where this is what it does. It imagines the split second future it's about to go experience, and then it knows how to go do the thing. And then you have like world models that are starting to accelerate in quite a way. And I don't mean the world labs world models. I mean like the world models that understand physics and cause and effect in lots of settings. To me, this sounds like this is a huge risk to Bifrost, and Bifrost doesn't really need to exist in that world. Tell me where I'm right or wrong.
Yeah. So there's two parts of that, right? There's two futures. One future is imagine intelligence is solved, right? You have a brain that can work anywhere. Say, physical intelligence and skill. They released the final API, right?
The final
API. They can do anything and everything.
That's a cool idea. Right? I'm writing that down. Final API. It's a catchy title for some kind of essay.
All these credits, man. I gotta line up these credits.
This one I might not give you credit for. I might just steal it, but that's okay.
It's now in the world. Everyone knows. So do with that what you will.
Indeed. So you mentioned you have the final API, right? And you are working in a science lab, right? And you're like, okay, I can't hire any lab assistants. Let's go buy a Unitree G7. And then we're going to load up the physical AI API. And I want it to do all these very domain-specific tasks for me. Are you going to just load it up and hope it works in the lab? Or are you going to load it up and run it through a whole bunch of specific scenario tests and make sure you can do the task first before loading it into the real robot? So our thesis is actually that you won't need training at all in the future, but you will need very thorough, rigorous evaluations for domain-specific things, right? So it's like you want to do it for domain-specific tasks, you will need to evaluate it for your domain-specific things, and you can't just evaluate it in real life across the 1,000 scenarios that you want it to do. And every time a new update comes or a new, you just fine-tune on the edge and you update the model, you still want to CI/CD your model, right? So there will always be a need for testing, simply because we're just deploying the systems into the real world where real infrastructure, real lives are all at risk, right? So for us, and we see that happening today as well, right? Like most of our customers actually use us for eval more than use us for training, right? So we're seeing that shift slowly, where it's more eval centric. But to Charles's point, everyone's like, okay, if we can load up a world model, a world action model, and we do test time inference, right? So we roll up 10 different policies. And like this is like approach 1x takes as well. They highlighted recently as well. But I think there's a few problems there. One is taking a world model and running it at test time inference is crazy because you need to do 40 different rollouts in faster than real time on an edge device. What you will need is you will need an abstracted, low resource, low compute way of rolling out these scenarios. And if you have a 3D representation that is low resource, low compute, you can actually roll out things much, much faster. Right? And we think that's like, it could be another thing, but that's like much, much further down the road. For us, like the main thing is like focusing on evals. But if we could become that imagination engine, and that's like that moonshot thing, right? Imagination engine that can actually run on edge compute. That's a thing that we're trying to work. And it's actually a tractable problem. It's just like, okay, when is the right time to get into that market?
Yeah, we believe it's a compute problem, and that compute problem will be solved eventually, right? We are going to build that evaluation framework for robots to imagine whether they're, plugged into an Ethernet cable and interfacing with something else, or they're doing it on their own brains. The difference is just a compute problem, right? So we build a framework now. We build a great evaluation framework now. We integrate all the latest models, that all these labs are coming up with, right? We create that easy test bed for any developer to, quickly activate self-learning on their own robots. And it's only a matter of time until robots get smart enough where you can actually just put in their own brains. So
very cool. I'm excited to see this eval platform and product. So I'm seeing a lot of these eval products pop up. Before we wrap, I'm curious, how are you guys, and we've kind of danced around it a little bit here, I've gotten a signal, some sense of that, but what's going to make your eval product different? And then, I'm thinking about like the Light Wheels of the world. There's a few other companies like this. How do you think about really being differentiated as an eval platform?
You will see in a month.
It hasn't launched yet. Sorry. It's launching in a month. Got it.
Yeah. We're going live in a month.
Well, I think we should do a round 2 then after this thing is live, and maybe we can get a live demo. Actually, be really cool if you guys were open to it.
Yeah, that would be cool.
Yeah, let's line that up.
Yeah, but I think we see the same as it's a whole bunch of eval platforms, but I think it doesn't solve one of the main problems. But we will talk more about that maybe some other time.
Okay, yeah, let's leave a little meat in the bone, leave people wanting more. So, final question. This is a great conversation, so I appreciate it. Excited to get this one out there. This is more of a philosophical question, and I'm on a holy mission to collect really good questions. And so I'm seeking not an answer, but a question here. And the question I'm seeking is, as humanity faces this exponential takeoff, this crazy era of change we're heading into, what do you think is the most important question that we should be asking ourselves to best prepare and thrive in that future? And that could be as individuals, as a society, either one. I love a question from each of you, if you have one.
Charles?
Give this a little thought.
Yeah, take your time.
I can go first.
Sure.
While
Yeah.
Charles is.
Go ahead. I was just about to start, but you go ahead.
Yeah. So I think my answer may not be what you want to hear, but for me, it's like, dude, life's not that deep, man. It's like, first, like, do things you enjoy with like the people you enjoy with, like you enjoy their company with. I think like every technological revolution always scares people. Was it like agriculture? We had like that whole migration of workforce there, whether it was like computers. I think over time it just frees us up to just do more things. Like even now, like all these like AI agents coming out, people have become more busy managing the agents, which is crazy because the expectations of productivity have gotten higher. It's like, oh, last time your throughput was X, but with this AI agent, it needs to be 10X. So therefore, you need
Exactly.
to be more busy. So it's like, I need to go learn these additional tools as well. So it's like, I think there will always be an evolution of what work means, but I think the constant throughout it all is just like, hey, are you enjoying your time on this planet? Are you like, contributing to the relationships that you're building? Are you having fun doing it? Are you like giving back to your community? I think these like the base things that don't really change throughout time. It's like your tribe, your people, your relationships, and like how you experience life. So like, for me, it's like, I don't want to go down the route of becoming a philosopher. The most of them are depressed. They think too much and they ask too much deep questions. So for me, it's like I try to keep it simple.
I love that. I love that.
Yeah. No, my mind didn't stray too far from yours, I think, but it's less of a question. My mind, I was struggling to get to a question to be asked, and more of a personal tenet that I would probably hold to myself, which is like, this is less of a if robotics takes over the world kind of question, but more like stuff that I've personally reflected on and come to a conclusion on myself. Having been a founder for a while, having been so immersed in the world of technology, there's so much going on all the time. The noise is insane. The signal is insane everywhere, right? And like, even in the course of our work, we work with NASA, we work with the government, we work with robotics companies. These are all high impact, big deals, right? And I realize, at the end of the workday, after a day of like energizing conversation, lots of great technical work, all these things, where I come back to what do I care about truly is my community, right? Like I think the 99.9999% of human brains were not designed to think about the world as a whole and shoulder its burdens that right, crushing, right? And even reflecting on myself as a younger founder, like trying to contend with that and somehow function was a lot, right? Ultimately, at the end of the day, what I came back and cared about, not too different from Arvind's reflection, is just my community, right? My loved ones, my family, my friends, right? And if it doesn't matter if you're a founder or it doesn't even matter if you're in tech, you're just doing other stuff, regular human stuff. Community is everything, right? And whatever you can do to drive impact, the love in your community, that's what matters, I feel.
Yeah. And end of the day, this is just, we're all playing this video game, right? And it's the quest you give yourself, right? No one is giving you the quest. Like, up to you to give yourself what quest you want to play as well. So I think it's up to everyone to choose their own adventure as well.
What quest and what tribe, and how are you cultivating that tribe, aka community? I think is a good compression of both your questions. Wow, that was awesome. I love both those answers. I'm excited to share this one with the world, guys. Let's definitely do a round 2 so we can actually maybe show off the product. It's very visual, inherently visual experience, right?
Indeed.
And yeah, appreciate your time and look forward to the next one.
Likewise. Awesome.
Cool.
Alrighty. Where did it fail? How do we improve this? How do we collect more real data? Improve the data set, retrain, redeploy, yada, yada, right? For humans, let's say we go to work, we make a mistake. What happens? We go home, we reflect, we ruminate, we play out several scenarios in our mind of how this could have been better. And then tomorrow we come back to work, we do a better job. There was no retraining, right? There was no, figuring out, collecting more real data and practicing until we get it right. You could just, for many tasks, right? You can just sit and reflect and imagine, right? So I like to think of imagination as a proxy for this. Where like eventually robots will get to such a point where they are able to autonomously imagine and self-learn and self-correct on the job, where this paradigm of like taking it back and retraining, whether with real or synthetic data, that will subside or like reduce significantly. Yeah.
What's the role of your business in that future? I mean, that could come pretty quickly. Like I just had a meeting with a customer that's building a not a VLA, but a video action model where this is what it does. It imagines the split second future it's about to go experience, and then it knows how to go do the thing. And then you have like world models that are starting to accelerate in quite a way. And I don't mean the World Labs world models. I mean like the world models that understand physics and cause and effect in lots of settings. To me, this sounds like this is a huge risk to Bifrost, and Bifrost doesn't really need to exist in that world. Tell me where I'm right or wrong.
Yeah. So there's two parts of that, right? There's two futures. One future is imagine intelligence is solved, right? You have a brain that can work anywhere. Say my physical intelligence and skill, they released the final API, right?
Yeah, the final
API they can do anything and everything.
That's a cool idea. Right? I'm writing that down. Final API. It's a catchy title for some kind of essay.
All these credits, man. I gotta take these credits.
This one I might not give you credit for. I might just steal it, but that's okay.
Our contribution to AI groupie, so do with that what you will.
Indeed. So you mentioned you have the final API, right? And you are working in a science lab, right? And you're like, okay, I can't hire any lab assistants. Let's go buy a Unitree G7. And then we're going to load up the physical AI API. And I want it to do all these very domain specific tasks for me. Are you going to just load it up and hope it works in the lab? Or are you going to load it up and run it through a whole bunch of specific scenario tests and make sure it can do the task first before loading it into the real robot? So our thesis is actually that you won't need training at all in the future, but you will need very thorough, rigorous evaluations for domain-specific things, right? So it's like you want to do it for domain-specific tasks, you will need to evaluate it for your domain-specific things, and you can't just evaluate it in real life across the 1,000 scenarios that you want it to do. And every time a new update comes or a new, you just fine-tune on the edge and you update the model, you still want to CI/CD your model, right? So there will always be a need for testing simply because we're just deploying the systems into the real world where real infrastructure, real lives are all at risk, right? So for us, and we see that happening today as well, right? Like most of our customers actually use us for eval more than use us for training, right? So we're seeing that shift slowly where it's more eval centric. But to Charles's point, everyone's like, okay, if we can load up a world model, a world action model, and we do test time inference, right? So we roll up 10 different policies. And this is approach 1x takes as well, already highlighted recently as well. But I think there's a few problems there. One is taking a world model and running it at test time inference is crazy because you need to do 40 different rollouts in faster than real time on an edge device. What you will need is an abstracted, low resource, low compute way of rolling out these scenarios. And if you have a 3D representation that is low resource, low compute, you can actually roll out things much, much faster, right? And we think it could be another thing, but that's much, much further down the road. For us, the main thing is focusing on evals. But if we could become that imagination engine, and that's that moonshot thing, right? Imagination engine that can actually run on edge compute. That's a thing that we're trying to work. And it's actually a tractable problem. It's just okay, when is the right time to get into that market?
Yeah, we believe it's a compute problem, and that compute problem will be solved eventually, right? We are going to build that evaluation framework for robots to imagine, whether they're, plugged into an Ethernet cable and interfacing with something else, or they're doing it on their own brains. The difference is just a compute problem, right? So we build a framework now. We build a great evaluation framework now. We integrate all the latest models, that all these labs are coming up with, right? We create that easy test bed for any developer to, quickly activate self-learning on their own robots. And it's only a matter of time until robots get smart enough where you can actually just put in their own brains. So
very cool. I'm excited to see this eval platform and product. So I'm seeing a lot of these eval products pop up. Before we wrap, I'm curious, how are you guys, and we've kind of danced around it a little bit here, I've gotten a signal, some sense of that, but what's going to make your eval product different? And then, I'm thinking about the Light Wheels of the world. There's a few other companies like this. How do you think about really being differentiated as an eval platform?
You will see in a month.
It hasn't launched yet. Sorry. It's launching in a month. Got it.
Yeah. We're going live in a month.
Well, I think we should do a round 2 then after this thing is live, and maybe we can do a live demo. Actually, be really cool if you guys were open to it.
Yeah, that would be cool.
Yeah, let's line that up.
Yeah, but I think we see the same as it's a whole bunch of eval platforms, but I think it doesn't solve one of the main problems. But we will talk more about that maybe some other time.
Okay, yeah, let's leave a little meat on the bone, leave people wanting more. So, final question. This is a great conversation, so I appreciate it. Excited to get this one out there. This is more of a philosophical question, and I'm on a holy mission to collect really good questions. And so I'm seeking not an answer, but a question here. And the question I'm seeking is, as humanity faces this exponential takeoff, this crazy era of change we're heading into, what do you think is the most important question that we should be asking ourselves to best prepare and thrive in that future? And that could be as individuals, as a society, either one. I love a question from each of you, if you have one.
Charles?
Give this a little thought.
Yeah, take your time.
I can go first.
Sure. Yeah.
Charles is.
Go ahead. I was just about to start, but you go ahead.
Yeah. So I think my answer may not be what you want to hear, but for me, it's like, dude, life's not that deep, man. It's like, first, like, do things you enjoy with like the people you enjoy with, like you enjoy their company with. I think like every technological revolution always scares people. Was it like agriculture? We had like that whole migration of workforce there, whether it was like computers. I think over time it just frees us up to just do more things. Like even now, like all these like AI agents coming out, people have become more busy managing the agents, which is crazy because the expectations of productivity have gotten higher. It's like, oh, last time your throughput was X, but with this AI agent, it needs to be 10X. So therefore, you need to be more busy. So it's like, I need to go learn these additional tools as well. So it's like, I think there will always be an evolution of what work means, but I think the constant throughout it all is just like, hey, are you enjoying your time on this planet? Are you like, contributing to the relationships that you're building? Are you having fun doing it? Are you like giving back to your community? I think these like the base things that don't really change throughout time. It's like your tribe, your people, your relationships, and like how you experience life. So for me, it's like, I don't want to go down the route of becoming a philosopher. The most of them are depressed. They think too much and they ask too much deep questions. So for me, it's like, I try to keep it simple. Charles.
I love that.
Yeah. No, my mind didn't stray too far from yours, I think, but it's less of a question. My mind, I was struggling to get to a question to be asked, and more of a personal tenet that I would probably hold to myself, which is like, this is less of a if robotics takes over the world kind of question, but more like stuff that I've personally reflected on and come to a conclusion on myself. Having been a founder for a while, having been so immersed in the world of technology, there's so much going on all the time. The noise is insane. The signal is insane everywhere, right? And like, even in the course of our work, we work with NASA, we work with the government, we work with robotics companies. These are all high impact, big deals, right? And I realize, at the end of the workday, after a day of like energizing conversation, lots of great technical work, all these things, where I come back to what do I care about truly is my community, right? Like I think the 99.9999% of human brains were not designed to think about the world as a whole and shoulder its burdens that right, crushing, right? And even reflecting on myself as a younger founder, like trying to contend with that and somehow function was a lot, right? Ultimately, at the end of the day, what I came back and cared about, not too different from Arvind's reflection, is just my community, right? My loved ones, my family, my friends, right? And if, it doesn't matter if you're a founder or, it doesn't even matter if you're in tech, you're just doing other stuff, regular human stuff. Community is everything, right? And whatever you can do to drive impact, the love in your community, that's what matters, I feel.
Yeah. And end of the day, this is just, we're all playing this video game, right? And it's the quest you give yourself, right? No one is giving you the quest. Like, up to you to give yourself what quest you want to play as well. So I think it's up to everyone to choose their own adventure as well.
What quest and what tribe, and how are you cultivating that tribe, aka community? I think is a good compression of both your questions. Wow, that was awesome. I love both those answers. I'm excited to share this one with the world, guys. Let's definitely do a round 2 so we can actually maybe show off the product. It's very visual, inherently visual experience, right?
Indeed.
And yeah, appreciate your time and look forward to the next one.
Likewise. Awesome.
Cool.
Alrighty.
Thanks for listening to Dream Machines. If you enjoyed this episode, please consider sharing with a friend. And if you happen to have a few seconds, leave us a rating on your favorite podcast player. It's super appreciated and really helps us grow and spread the good word. Oh, and don't forget to check out our newsletter over at dreammachines.ai, where you'll find essays and deep dives on companies, founders, and big ideas in this domain. Thanks again for the time. See you on the front lines.